Today we're going to be doing long division and doing a couple examples. First off without any variables, and then later on we're going to do ones with variables. So to start, we're going to do 1,347 divided by 6. And when you're doing long division, you want to write out some of the multiples on the side just so it makes it easier for you later. To start, what we're going to do is we're going to work on each number by itself. So we're going to work on the 1, and we're going to see that 6 goes into 1 0 times. So we're going to write a 0 up top, and we're going to subtract 0 from it, which just gives us 1 again. Now what we're going to do is we're going to bring down our second number, 3. And we'll see that 6 no longer goes into 13 0 times. It goes into it 2 times, which is 12. So I'll write a 2 up top, and we'll subtract 12, giving us 1. Now what we're going to do is we're going to bring down our 4, give us 14, and we're going to look to our table again, and we're going to try to find the number that is closest to 14 while being smaller than 14, which is 12 again. So we're going to write a 2 up top, and we're going to subtract 12 from the bottom, giving us 2 this time. Now we'll bring down the 7, and we'll do the same thing. We're going to look for the number that's closest to 27 while being less than 27. So the closest one is tied from 24 and 30. We can't use 30 because it's too large. So we're going to use 24, and we'll see that it's 6 times 4. So we're going to write a 4 up top and subtract 24 here, giving us 3. Now, you can leave this as a remainder at the end, or if you think you can go a little bit further, you can write a decimal at your answer and at what we're dividing, and we'll add a 0 beside it so that we can bring down the 0 and try to keep going to see if the decimal is infinite or if it stops eventually. For this one, it's nice and easy because we know 6 times 5 is 30, so we can write a 5 up top, and we can subtract 30 to give us a remainder of 0. So we know that our answer of 1,347 divided by 6 is 224.5. But you could also write it as 224 with a remainder of 3. Our second question is going to be 980 divided by 14, and I've taken a little bit of time to write out all the multiples of 14 on the side to make this a little bit easier for us. So to start, we'll work on the 9, and we'll see that 14 goes into 9 0 times because 9 is smaller than 14. So subtract 0, giving us 9 again, and we'll bring down our second number to make it 98, which if we look at our chart on the side, we'll see that 98 is 14 multiplied by 7. So we can write 7 up top and subtract 98 from it, giving us 0. But we're not done. We still have to write the 0 and bring it down, even though it doesn't mean anything. And obviously 14 goes into 0 times, so we can write a 0 up top, note giving us that 980 divided by 14 is 70. So even if there's a 0 and it is all zeros down low, you still have to write the 0 up top, or else your answer won't make any sense. So now we ramped up the difficulty quite a bit. We have 567,890 divided by 16. So we'll take this nice and slow and go step by step, and it won't be too bad. So to start, we'll notice the 5. We know that 16 goes into 5 0 times because 16 is larger than 5. Now we can bring down the 6, and we'll have 56. And I already wrote all the numbers on the side, so it's nice and easy. We're going to look for the number that's closest to 56 while being less than 56, which we'll see here is 48. So we'll put a 3 up top, and we'll subtract 48 from 56, giving us 8. Now, same step, just bring down the next number, which is a 7. Now just look to your chart. And here we'll see that 16 multiplied by 5 is 80, which is the closest to 87. So we'll subtract 80, giving us a remainder of 7. and we got to remember to put the 5 up top. And just rinse and repeat the same steps, bring down the 8, and we'll look for the number closest while being less than 78, which for us will be 64, which is 16 multiplied by 4, so we'll put the 4 up top, and we'll subtract 64, giving us 14. Now bring down the 9, and we're going to do the same steps, just a little bit longer. We'll see that 16 multiplied by 9 is 144, which is the closest, and we'll subtract 144 from the bottom, giving us 5. And if you remember from the last question, we can't forget the 0, it's very important. And we're going to look for the number closest to 50, which is 16 times 3, which is 48. So we'll write 3 up top, and we'll subtract 48 from here, giving us a remainder of 2 at the end. So either you could say that your remainder is 2, or you could try to do a couple decimals to see if it works out nice, which is what we're going to do. So we're going to write a decimal, and we'll try to bring it down. So 20, and we'll see that that's only 1, so minus 16 gives us 4. And I'll put that right, we'll bring this up a little bit higher just so we have enough space. I'll put 20 minus 16 gives us 4. And that's, we're going to put a decimal up top and write a 1. Now we're going to write another 0 and bring this one down. It gives us 40. So we'll notice that this is 16 multiplied by 2, it's 32. So I'll write a 2 up top, and we'll subtract 32, giving us 8. And we'll see that this question does actually work out perfectly, because we're going to write one last 0, bringing it down, and we'll notice that 16 multiplied by 5 gives us exactly what we're looking for, which is 80. So we can subtract 80 and have a remainder of 0 instead. So either you could write your answer as 35,493.125, or you could write your answer as 35,493 with a remainder of 2, depending on what your teacher is looking for. Now our final question is going to be adding variables into our long division. So we've already done a hard question, so now we're going to ramp it up just a little bit more, making it 6x squared minus 5x plus 3 divided by 2x minus 1. Now this question does make it a little bit different, but it's not going to be too bad. So since we have a polynomial here with 2 different numbers, we have to skip our first step of writing the 0 here because we have 2 numbers. So this has to be ignored. We have to go straight to here. So what the first step is we're going to try to match our first number, which is our 2x, to their first number, which is 6x squared. So we can do this by making it multiplying both the 2x minus 1 and negative 1 by 3x. So we'll see that 2x multiplied by 3x gives us 6x squared. And now we're going to keep the sign the same. Our 1 multiplied by 3x gives us 3x. Now 6x squared minus 6x gives us 0, which is what we're looking for. And our negative 5x minus negative 3x will give us negative 2x. Now what we can do here is we're going to have to subtract one more time, but we want our 2x to get rid of this negative 2x. But a negative minus a positive is going to give another negative. So we have to change the sign. So we know that this is going to have to be a negative because we want a negative minus a negative, because that will cause them to cancel out. But we don't need to change the 2x at all because it's already in 2x. So we're going to have it subtracted by 1 here. So we're going to subtract negative 2x. And we're going to bring down the plus 3, like always, with long division. But our negative 1 is now going to become a plus 1. So this negative 2x and our negative 2x cancel out, and we're left with 3 minus 1, giving us a remainder of 2. So when we're doing division of polynomials, we're not actually able to keep adding zeros at the end to get rid of our remainder because we have our 2x here. As soon as we add a 0, there's nothing here anymore. This would be 20. This is one number, but we still have two numbers up here. So we're unable to go past our remainder. So we know that 6x squared minus 5x plus 3 divided by 2x minus 1 is equal to 3x minus 1 with a remainder of 2.